If A dash is equal to A, then it is said to be a symmetric matrix. All the elements above the principal diagonal must be equal to elements below the principal diagonal. Find a matrix X such that 2A plus X is equal to 3B. Dear students, welcome to this session of mathematics class. I am Mr. M.J. Niranjan, lecturer in mathematics, Vidhyaashram PU College. Today I am going to discuss regarding symmetric and skew symmetric matrices, problems based on symmetric and skew symmetric matrices, as well as some additional problems which we have discussed in previous classes. Based on those concepts, I am going to do some more problems which are very important for the point of examination. Now, let us discuss regarding symmetric and skew symmetric matrix. First of all, symmetric matrix. Symmetric matrix means it's a square matrix. A square matrix A is equal to Aij is said to be a symmetric matrix if A dash is equal to A. If A dash is equal to A, then it is said to be a symmetric matrix. So, that is if Aij is equal to Aj for all the values of I and j. So, that means if you transpose the matrix, you are going to get a same matrix. Such a matrix is called a symmetric. Symmetric with respect to principal diagonal. If you fold along the principal diagonal, you will get the elements. All the elements above the principal diagonal must be equal to elements below the principal diagonal. So, let us consider an example. I will take one small example. A is equal to 2, 3, 3, 4. So, if I transpose this, the transpose of this is first row becomes first column, 2, 3, 3, 4. See, 2, 3, 3, 4, here A dash is equal to A. The transpose will remain the same. If you transpose, you will get the same matrix. Such a matrix is called as a symmetric matrix. A matrix, a square matrix A is said to be symmetric if and only if A dash is equal to A. That is, if all the elements above the principal diagonal must be equal to elements below the principal diagonal. If you fold along the diagonal, these elements will coincide with. So further, if I transpose this, A dash is equal to same matrix. This is in case of 2 rows and 2 columns. Let us consider one more example in 3 rows and 3 columns. Let us come to this problem. Here, A is equal to 1, 4, 5, 4, 2, 6, 5, 6, 3. Transpose this. The transpose of this is A dash is equal to, so first row becomes first column, second row becomes second column, third row 5, 6, 7, 5, 6, 7, it won't changes. The matrix will remain the same. That is, all the elements above the principal diagonal must be equal to elements below the principal diagonal. See, 4, 5, 6, 6. Elements above principal diagonal are same as elements below the principal diagonal. Such a matrix is called a symmetric matrix. So, in general, if you transpose any matrix, a square matrix, if you transpose a square matrix, if you get the same matrix, such a matrix is called a symmetric matrix. So, here, a square matrix A is said to be symmetric if and only if A dash is equal to A, the transpose is equal to same matrix. These are the example for symmetric matrices. Now, let us take one more example, symmetric matrix. All the elements above the principal diagonal are equal to elements below the principal diagonal. Suppose if I take A is equal to 4, 5, 4, 5, 4, 2, then transpose this A dash is equal to, you will get, so here you will get A dash is equal to 4, 5, 4, 2. So here the transpose of this, so 4, 5, 4, 2. So 4, 5, 4, 2. See here, transpose of this. This is not a symmetric matrix because see here, if I transpose this, I won't get the same matrix. See here, there is a change. See here, because the elements above the principal diagonal are not equal to elements below the principal diagonal. So this is not an example for a symmetric matrix, just it is a square matrix. Whereas this matrix, come to this matrix. So if A is equal to this matrix, A is equal to 4, 6, 6, 7, the transpose of this 4, 6, 6, 7, you will get the same matrix. This is an example for a symmetric matrix, whereas this is not an example for a symmetric matrix, provided if these two elements are same. If I write A is equal to 4, 5, 5, 2, then transpose this A dash is equal to 4, 5, 5, 2. So you will get A dash is equal to A, then it is called a symmetric matrix, whereas this is not an example for a symmetric matrix. So that is the difference. No, so you just notice the difference here. This is not a symmetric matrix because the diagonal elements are not, the elements above the principal diagonal are not same, because it is 5, it is 4. Further, if I transpose, I won't get the same matrix. Therefore, this is not a symmetric matrix. Whereas if I take this matrix, A is equal to 4, 6, 6, 7, transpose this, A dash is equal to 4, 6, 6, 7, you will get the same matrix, then it is a symmetric matrix. If instead of writing 4 here, if I change 4 to 5, then these two elements are same, then you are going to get a matrix. A dash is equal to same matrix. Such a matrix is called a symmetric matrix. In the examination, they may ask, if A is equal to 3x 4 2 is a symmetric matrix, find x. For 1 mark it is. The examination, if A is equal to 3x 4 2 is a symmetric matrix, find x. Very simple. According to definition of a symmetric matrix, what is the definition? A dash is equal to A. Now transpose this matrix. You transpose this 3x 4 2 is equal to same matrix 3x 4 2. So here what you will get? See here, the value of x here is equal to 4, the value of x here is equal to 4. So therefore, the value of x is equal to 4. That's all. Very simple question it is. So it's a simple problem. Right. Now let us take one more problem based on skew symmetric. Let us come to the definition of a skew symmetric matrix. Skew symmetric matrix means a square matrix A is equal to Aij, ijth element is said to be skew symmetric matrix if A dash is equal to minus A. If you transpose that matrix, you are going to get a negative matrix. A dash is equal to minus A, that is, all the elements above the principal diagonal must be equal to elements below the principal diagonal but opposite in sign. Further, all the principal diagonal elements are zeros. That is why Aij is equal to minus Jia for all the values of I and j. So I will take example. For example, if A is equal to 0, 3, minus 3 and 0. This is an example for a skew symmetric matrix. Just transpose this. A dash is equal to 0, 3, minus 3 and 0. See here, this is nothing but minus of A. This matrix A is multiplied by negative sign. You will get 0, minus 3, plus 3 and 0, 0, minus. So therefore, A dash is equal to minus A. This is an example for a skew symmetric matrix. So first of all the elements above the principal diagonal are same but opposite in sign, and this principal diagonal element must be equal to 0. That is here like this. That is, for a skew symmetric matrix, A dash is equal to minus A. If I is equal to j, Aij is equal to minus of ji. Further, all the elements 2 times A11, that is A11 is equal to 0, A22 is equal to 0, A33 is equal to 0. That means this is A11 is 0, A11, A12, A13, A21, A22, A23, A31, A32, A33. That means this A11, A22, A33 are zeros. That means you will get 0, A12, A13, again A21, this is 0, A23, this is A31, A32 and 0. Further, Aij is equal to minus. So if this is positive, then this is negative. If this is negative, then this is positive. If it is the so this is a skew symmetric matrix. So in the skew symmetric matrix, all the principal diagonal elements are same, zeros, and above the elements, all the elements above the principal diagonal must be equal to elements below the principal diagonal, but opposite in sign. Further, the transpose is equal to negative, you are going to get. Let us consider an example in case of 3 rows and 3 columns. Let us consider an example. A is equal to 0, 4, 5, minus 4, 0, 6, minus 5, minus 6 and 0. The transpose of this is transpose 0, 4, 5, minus 4, 0, 6, minus 5, minus 6. So see here all these positive elements will convert to negative and this negative becomes positive, that is nothing but minus A. Further, the elements in the principal diagonal are zeros. So this is an example for a skew symmetric matrix of order 3 rows and 3 columns. So a square matrix in which a square matrix A is said to be skew symmetric if A dash is equal to minus A. Further, all the elements in the principal diagonal are zeros and elements above the principal diagonal must be equal to elements below the principal diagonal but opposite in sign. A dash is equal to minus A. It's a very important definition. Now, that is all the elements in the principal diagonal are 0 and all the elements above the principal diagonal are equal to elements below the principal diagonal but opposite in sign. Let us consider this example. B is equal to 0, 3, minus 2, minus 3, 0, 1, 2, minus 1, 2. If I transpose this, first row becomes 0, 3, minus 2 becomes first column, minus 3, 0 becomes second column, 2, minus 1, 0 becomes third column. So further B dash is equal to minus B. Wherever there are negative signs here, you will get positive signs here. So B dash is equal to minus B. This is an example for a skew symmetric matrix. Let us take one more example. If I take another example, if C is equal to 0, 3, minus 2, minus 1, 0, then this is, let me write 4, then minus 4, plus 2 and 0. See here this is not a skew symmetric matrix because all the elements above the principal diagonal are not equal to below the principal diagonal. This is 3, this is not equal to minus, so this is minus 4, this is not equal to this. So this is not a skew symmetric matrix. Suppose if I write like this 0, 0, 0. So 2, minus 3, plus 4, then this is minus 2, then minus 4 and this is plus 3 and minus 4. So see, this is plus 2, minus 3, plus 3, plus 4, minus 4. This is an example for a skew symmetric. Transpose this 0, 2, minus 3, minus 2, 0, 4, 3, minus 4 and 0. Here C dash is equal to minus C. This is an example for a skew symmetric, whereas this is not an example for a skew symmetric matrix, right? So symmetric matrix means A dash is equal to A. Skew symmetric matrix means A dash is equal to minus C. That's all. That is the difference. Let us take a few more examples on a symmetric and a skew symmetric matrix. So let us take if A is equal to 2, 4, 4, 5. So if I transpose this, A dash is equal to 2, 4, 4, 5. This is a symmetric matrix. So this is an example for a symmetric matrix. Now another example for skew symmetric matrix is same just. So write down first elements as 0, 0 in the principal diagonal. You can give any elements here. So this is minus 4, minus 3, 2 and plus 2. So if I transpose this, A dash is equal to 0, 4, 3, minus 4, 0, 2, minus 3, 2 and 0. A dash is equal to minus A. So this is a skew symmetric matrix. Skew symmetric matrix. So this is an example for a symmetric matrix and this is an example for a skew symmetric matrix. Now let us come to the problems. Some additional problems. Additional problems based on whatever we have discussed in the previous classes like addition, subtraction, scalar multiplication, matrix multiplication, symmetric and skew symmetric. Now what is the problem given? If A is equal to 1, minus 1, 2, 3, I is equal to 1, 0, 0, 1, show that A into I is equal to I into A is equal to A. That means if you multiply any matrix with an identity matrix or identity matrix into any matrix of same order will give the same matrix. That means if you multiply any matrix with an identity matrix of same order or identity matrix with any matrix of same order, then you are going to get the same matrix. Let us check here. First, I will take A into I. What is A? 1, minus 1, 2 and 3. I is 1, 0, 0, 1. So this is matrix multiplication, revision. Again, revision of matrix multiplication. So matrix multiplication, first row, first column, second row, first column, second column. So that's all. That is, multiply this. So first row, first column, 1 into 1 is 1, minus 1 into 0 is 0. Again, same row, second column, 1 into 0 is 0, minus 1 into 1 is minus 1. First row, first column, second column, finished. Now come to the second row. 2 ones are 2, plus 3 into 0 is 0. 2 into 0 is second row, second column, 2 into 0 is 0, plus 3 into 1 is 3. This is equal to 1. 0 minus 1 is minus 1. 2 plus 0 is 2. 0 plus 3 is equal to 3. 1 minus 1, 2, 3. That is nothing but our same matrix C. So that means, therefore, any matrix into identity matrix is equal to same matrix. Suppose, on the other hand, if I multiply identity matrix with any matrix, identity matrix 1, 0, 0, 1, and the matrix is 1, minus 1, 2, 3. According to the definition, I will get the same matrix A. Let me check. Same, first row, first column, second column. So this is 1 into 1 is 1, 0 into 2 is 0, 1 into minus 1 is minus 1, plus 0 into 3 is 0, 1 into 0 is 0, plus 1 into 2 is 2, 0 into minus 1 is 0, plus 1 into 3 is equal to 3. So 1, minus 1, 2 and 3. So this is 1 minus 1, 2, 3. 1 minus 1, 2, 3 is again equal to the same matrix. Therefore, what is say? I into A is equal to A. So that means, if you multiply any matrix with an identity matrix or identity matrix with any matrix of same order, you will get the same matrix. So therefore, from 1 and 2, from these two equations, 1 and 2, this is 1 and this is equation number 2. From 1 and 2, what we can say, conclude that A into I is equal to I into A is always equal to A. So A into I is equal to I into A is equal to A. So this is an additional problem. Now let us come to one more problem. Let us take this problem. So this is also very important 3 marks question. You may get this type of questions for 3 marks, additional questions. What is given? Find X. Condition, 3 matrices are given. If 1 to 1, a matrix of order 1 row 3 column, another matrix 1 2 0 2 0 1 1 0 2, a matrix of order 3 rows and 3 column, another matrix of order 3 rows 1 column are given. Matrix, multiply it and equate it to a 0, then you are going to get a linear equation or a quadratic equation. Solve. That's all. Very simple. So let us multiply any these two. Let us multiply these two. Check whether it is possible to multiply or not. Since the order, this is 3 into 1, this is 3 into 1, 3 into 3, 3 into 1. So we can verify these two elements are equal. We can multiply. So just I keep this 1 to as it is, 1 to 1. Now multiply this. First row, first column. 1 into 0, 0, plus 2 into 2 is 4. Again 0 into x is 0. First row, first column. Again second row, first column. So that is 2 into 0, 0, plus 0 into any number is 0, plus 1 into x is x. Again last row, first column. 1 into 0 is 0, plus 0 into 2 is 0, plus 2 into x is 2x is equal to 0. This is 1, 2, 1. What is remaining? 4. 0 plus x is x. This is 2x is equal to 0. Check whether it is multiplied or not. This is 1 row, 3 column. This is 3 rows, 1 column. These 2 elements are same. So we can multiply and going to get a matrix of order 1 into 1. This is very important. So first row, first column, that is 1 into 4 plus 1 into 4 plus 2 into x plus 1 into 2x. This is equal to 0. That is matrix 4 plus 2x plus 2x is equal to 0. So 4x plus 4 is equal to 0. This is a matrix of order 1 into 1, 1 row, 1 column. So equate this to 0. Therefore 4x plus 4 is equal to 0, 4x is equal to minus 4, x is equal to minus 4 by 4 is equal to, so therefore the value of x is minus 1. Very simple. If you solve this much, you'll get 3 marks. Very easy question. Right, I will explain once again. So, just multiply any two matrices, either this and this or this and this. First multiply this. Verify whether it is possible to multiply it or not, since this is of order 3 rows 3 column, this is of order 3 into 1, these two elements are same. So, we can multiply this. So, 1 to 1 as it is first matrix, second and third matrix multiply, first row first column, 1 into 0 0, 2 into 2 is 4, plus 0 into x is 0, second row same first column, 2 into 0 0, 0 into 2 is 0, 1 into x is x, third row first column, 1 into 0 0, 0 into 2 is 0, plus 2 into 2 is 2 into x is 2x. Now this is 1 to 1 as it is, 4x and 2x. Now multiply these two matrices, check whether it is possible to multiply it or not. 1 row 3 column, 3 rows 1 column, these two are equal, and you are going to get a matrix of order 1 row and 1 column. This is very important, keep it in mind. The final matrix you are going to get is of order 1 row 1 column. Don't get confused. So only 1 row and 1 column is there. So first row first column, multiply this. 1 into 4 is 4, plus 2 into x is 2x, plus 1 into 2x is 2x. 4 plus 2x plus 2x, 4 plus 4x. This is a matrix of order 1 row 1 column, 4x plus 4 is one element. Now equate this to 0, 4x plus 4 is equal to 0, 4x is equal to minus 4, x is equal to minus 4 by 4 is minus 1. Therefore, the value of x is equal to, here x is equal to minus 1. So if you get this, if you solve this much, you easily get 3 marks in the examination. This is very important problem. Come to the next problem. We'll see next problem. What is the next problem? So this is very important problem. If a is equal to 1, minus 1, 2, 3, b is equal to 2, 1, 0, 1, find a matrix x such that, what is the condition given? 2a plus x is equal to 3b. So this is given. So given that 2 times a matrix plus another matrix x is equal to 3b. So here this matrix x is nothing but a matrix of order 2 rows and 2 columns, that is to be determined. So from this I can write x is equal to 3b and transfer this becomes minus 2a. So therefore the matrix x is equal to 3 times the matrix b minus 2 times the matrix a. So 3 into matrix b, what is b? 2, 1, 0, 1 minus 2 into a, 1 minus 1, 2 and 3. Simplify this. Multiply by 3, 3 2s are 6, 3 1s are 3, 0, 3 1s are 3, minus 2 1s are 2, 2 2s are 4, 2 2s are 4, 2 3s are 6. Subtract this, 6 minus 2 is 4, 3 minus into minus plus, 3 minus of minus 2, that is 3 plus 2 is equal to 5, this is 5, 0 minus 4 is minus 4, 3 minus 6 is minus 3. This is the required matrix. This is also of order 2 cross 2. Very simple. 3 marks question, 2 marks question it is. So for 2 marks, we are going to expect a question like this. So what is given? A 1 minus 1 2 3, B 2 1 0 1. Find a matrix X such that 2A plus X is equal to 3B. What is the given condition? 2 times matrix A plus the matrix X is equal to 3B. Then X is equal to 3B minus 2A. 3 into substitute B. What is B? 2 1 0 1 minus 2 into A. 1 minus 1 2 3. Scalar multiplication, multiply by 3, 3 into 2 is 6, 3 into 1 is 3, 3 into 0 0, 3 into 1 is 3, minus 2 into 1 is 2, minus 2 into 1 is 2, 2 2s are 4, 2 3s are 6. Subtract this, 6 minus 2 is 4, 3 minus of minus is plus 3 plus 2 is 5, 0 minus 4 is minus 4, 3 minus 6 is minus 3. So therefore the matrix X is equal to 4, 5, minus 4, minus 3. That is the required matrix. Now let us come to another problem. See here. This is very important 2 marks question again. Observe carefully what is given here. If A dash is given, A dash is equal to minus 2, 3, 1, 2 and B is equal to minus 1, 0, 1, 2, find A plus 2 B dash again. So A dash is given, A dash minus 2, 3, 1, 2. First find out A. A dash is given means A is equal to transpose this. Transpose of a transpose, we will get the same matrix. So A is equal to minus 2, 3, 1, 2. And B as it is minus 1, 0, 1, 2. Followed. Since A dash is equal to minus 2, 3, 1, 2 means A is equal to transpose of this. Transpose of first row becomes first column minus 2, 3, 1, 2 and B. Now take this. Now let us come to the problem. Now A plus 2B. First find out A plus 2B matrix. That is A. What is A? This is A. Not A. This one is A. Minus 2, 1, 3, 2 plus 2 times. What is B? Minus 1, 0, 1, 2. Simplify this. Minus 2, 1, 3, 2. Multiply by 2. 2 ones are 2, 0. 2 ones are 2, 2 twos are 4. So this is equal to minus 2 is minus 4. 1 plus 0 is 1. Again 3 plus 2 is 5. 2 plus 4 is 6. This is A plus 2B. Now therefore what is required to find is A plus 2B whole dash. The transpose of this. Transpose this. If you transpose, the first row become first column minus 4 and 1. Second row becomes second column 5 and 6. A plus 2B dash is equal to minus 4, 5, 1 and 6. That is the required answer. Very important question for 2 marks. Very simple. What is given? A dash is equal to minus 2, 3, 1, 2. Transpose this, you will get A. Transpose of this is minus 2, 3, 1 and 2. It is A. Again B as it is. Find out A plus 2B first. A plus 2B is equal to A. A is, use this as A. Minus 2, 1, 3, 2. Minus 2, 1, 3, 2. Plus 2 times B. Minus 1, 0, 1, 2. Multiply this with 2. 2 ones are minus 2. So 2 ones are 2. 2 twos are 4. Add. This is addition of matrices. Minus 2 is minus 4. 1 plus 0 is 1. 3 plus 2 is 5. 2 plus 4 is 6. This is A plus 2B. Transpose of this. Transpose this. A plus 2B whole dash is equal to minus 4, 1, 5 and 6 become first column. This is the required answer. Now coming to the next problem. Come to the next problem. Now what is the problem given here? If A is equal to 3, 1, minus 1, 2, prove that A square minus 5A plus 7I is equal to 0. So this type of problems already explained in previous classes. Let me do once again. What is given? A. First A square. Find out A square. A square is equal to A into A. What is A? 3, 1, minus 1, 2. Again 3, 1, minus 1 and 2. First row, first column, second column. Multiplied. 3 3s are 9. 1 into minus 1 is minus 1. 3 1s are 3. Again, first row, first column. 3 3s are 9. 1 1s are 1. Again, first row, second column. 1 3s are 3. Plus 1 2s are 2. Second row, first column. 1 3s are 3. Again, minus 2 1s are 2. Same second row, second column. 1 1s are 1 minus 1 plus 2 2s are 4. This is equal to 8. 3 plus 2 is 5 minus 5 and this is 3. A square. Now come to this. Now A square minus 5A plus 7I. Substitute here. So this is equal to 0. We have to prove. Let us take LHS. Now what is A square? A square is 8, 5 minus 5 and 3 minus 5 times A. What is A? 3, 1, minus 1, 2 plus 7 into I is an identity matrix of same order means 1, 0, 0, 1. That you should have to substitute. This is 8, 5 minus 5, 1, 3. Multiply by 5, 5 3s are 15. 5 1s are 5 minus 5, 5 2s are 10. Multiply by 7, 7, 0, 0, 7. Subtract these two. 8 minus 15 is minus 7. 5 minus 5 is 0. Minus into minus plus. 5 minus 5 gets cancelled 0. 3 minus 10 is minus 7. 7, 0, 0, 7. This is the easiest method. Now subtract, add. Minus 7 plus 7 is 0. This is 0. 0 minus 7 plus 7 is equal to 0. So this is your RHS. So therefore, what is A square minus 5A plus 7I is equal to 0, a null matrix. So first find out A square. A into A, substitute here A square minus 5A plus 7I, simplify, you are going to get it as 0, 0, 0, 0 as a null matrix. So, suppose if A is equal to 1, 2, 3, 4, B is equal to 2, minus 1, 0, 1, C is equal to 3, minus 1, 2, 1, find A plus B plus C. Second one, 2A plus B minus 2C. Now, let us take first one. I will solve the first one. First one is vector matrix A plus B plus C. 3 matrices. So, what is matrix A given? 1, 2, 3, 4 plus B. What is B? B is 2, minus 1, 0, 1 plus matrix C. What is C here? C is equal to 3 minus 1, then 2, 1. So, add this. Corresponding elements must be added. First element of first matrix, second matrix, third matrix. 1 plus 2 plus 3. First. Again second elements. 2 minus 1 plus into minus 1. Again 3 plus 0, 3 plus 0 plus 2. Again 4 plus 1 plus 1. So, this is equal to 3 plus 2, 5 plus 1 is 6. This is 2 minus 2 gets cancelled 0. Again 3 plus 2 is 5. 4 plus 1, 5 plus 1 is 6. This is a matrix of order 2 cross 2. You will get 2 into 2 matrix. Right. Similarly, come to the second one. Second one. What is second problem? So, 2 times matrix A. A is 1, 2, 3, 4 plus B as it is. What is B? 2 minus 1, 0, 1 minus 2 into C. What is C? 3 minus 1, 2 and 1. Simplify this. Just multiply this with 2 first. 2 into 1 is 2. 2 2s are 4. 2 3s are 6. 2 4s are 8. This is as it is. 2 minus 1, 0, 1. Again minus into multiply this. 2 3s are 6. 2 1s are 2. 2 2s are 4. 2 1s are 2. Now this is equal to same operation. This is plus and minus 2 plus 2. 2 plus 2 minus 6. Again 4 minus 1. 4 minus 1 minus of minus is plus 2. Again 6 plus 0 minus 4. Then 8 plus 1. 8 plus 1 minus 2. So this is equal to, simplify this, 2 plus 2, 4 minus 6 is minus 2. Again 4 plus 2 is 6 minus 1 is 5. Next, so 6, this is 0, 6 plus 0 is 0. 6 minus 4 is equal to 2. 6 plus 0 is 6 minus 4 is 2. Again 8 plus 1 is 9 minus 2 is equal to 7. This is 2 rows, 2 column. So, minus 2, 5, 2, 7 is the value of matrix 2A plus B minus 3C. If you want, you can add this and subtract with this, or straight away plus and minus, use the operation positive and negative, plus and minus. So, you will get the answer here. If you want, you can add these two and add this one and the same, or simultaneously you can add all the 3 elements. So, this is an additional problem. So, that is regarding symmetric, skew symmetric, and what we have discussed today is symmetric, skew symmetric, problems based on symmetric, skew symmetric, and few additional problems. That's for the day. Let's meet in the next class with new concept, determinants. Thank you.